Welcome you all once again. I'm here to talk about the case statements. So before I start, let me introduce myself. I'm Meghamala from Electronics and Communication Department, working as Assistant Professor and Institute of Aeronautical Engineering. Okay, so before we go forward, let me talk about something about the statements. Okay, so here, this is today's topic is about the case statement. So before going to that, in the previous sessions already we had discussed what are the different statements. Okay, different assignment statement. Basically, we have discussed what is an assignment. Okay, and what are the statements, assignment and statements, and different types of statements, and also various kinds of statements, which are the different keywords which are involved in the particular statements. Okay, so what is an assignment? Let's recapitulate. Let's recall the previous session. So what is an assignment? Assignment is nothing but the dumping of values into a variable. Okay, that means what? For example, my variables are a and b. Okay, so if it is if it is a circuit, a particular combination circuit, if these are my inputs and this is my output, so these are my inputs, right? So these are my variables, a, b and y are my variables. So to these variables I wanted to give some values. So assignment is nothing but dumping some values onto the variables is nothing but the assignment. Okay, so coming to the assignment, in the assignment, different types of sentences we have discussed. Okay, so net variables, assignment statements, different statements, net variable statements, and also declaration statement and delay statements, and all. Okay, so coming to the case statements. What does this case statements talks about? As you all know, this Verilog VHDL. Okay, this VHDL and C programming, there are almost we see 80% of similarities we will find in between these two languages, VHDL and as well as the C language. But remember that Verilog is a very case sensitive language. Okay, Verilog is a case sensitive language, and also you see the similarities as we discussed in the last class. There is similarities between when it comes to the conditional statements. Okay, for example, if you are considering any conditional statements and if you want to write a code in the HDL program, and also if you want to compare it with the C language, we see there is some almost all the similarities, maximum similarities we can find between the Verilog HDL and as well as the C program. Okay, and not only the conditional statements, and also when it comes to the case statement, we feel the almost it is like the same as the C program. So this case statements, what does this case statements tells about is this statements, it checks if the given expression matches one among the other expressions inside the list and the branches. So here inside the list, this is the list, right? So inside the list or the branches, the case statement, it will check. Okay, why it will check? Whether the statements are repeated or not, whether the statements are followed with this particular keyword or the parenthesis or not. Okay, so the case statements, it checks if the given expression matches. Okay, if it is matching with the other expressions or not in the list and as well as in the branches. If it is matching or not, this is the case statement. It will just have a glance, it will just look after into it whether it is matching or not. So all these things will be all the matchings with respect to the other expressions will be done only inside the list and as well as the branches. Okay, so it is typically accustomed to implement a device. So it is nothing but this case statement is typically used, okay, used to implement a device. So in order to implement a particular device, in order to develop a particular module, remember that the basic statements that we can use is a case statement. So it is typically used to implement a particular device. And in Verilog, A case statement includes all the code between Verilog keywords and end case. So this line is talking about in the Verilog, a case statement, it includes what? All of the code between the Verilog keywords and the end case. That means what? Verilog keyword. Verilog keyword is one of the keyword is module, right? When it comes to the keyword, we have discussed different types of keyword. Module, end module, begin, end, if, begin, end, and if else, isn't it? So these are the keywords that we had discussed in the module 1. So this Verilog, the case statement, it includes the code. That code should be in between the Verilog modules. That means what? Module, end module. So in between this, the case statements will be occurred. Okay, the case statements occurred only in between the Verilog keywords. Then a case statement can be a select one of many construct, that is roughly like associate in nursing if-else if statements. So in order to nurture this if-else if statement, we can see the case statement. It could be the case statement can be a select of one of many constructs. So here not only this case statement is pertaining to one particular statement, but also by using this if-else if condition, statements, the condition statements, the case statements can be applied more than once. Okay. Next, a Verilog case statements, it starts with the case keyword and ends with the end case keyword. So in this case statement, when you are writing a Verilog module or a Verilog syntax, you have to remember always that it starts with the case keyword. The program starts with the case keyword and as well as ends with the end case keyword. Then the expression with the parenthesis are unit aiming to be evaluated specifically once and is compared with the list of alternatives inside the order they are written. So inside the expressions with the parenthesis. The expressions with the parenthesis among aiming to be evaluated specifically. So for each and every statement, the expressions with the parenthesis, they should be evaluated, okay, evaluated specifically and is compared with the list. How these are evaluated? First one, okay, the statements with the parenthesis are evaluated specifically once, only once they will be evaluated, and then it is compared with the list of the alternatives inside the order. So inside this order, the sentences or the expressions with the parenthesis, they are evaluated and then they are compared. Okay, evaluation and comparison between the statements can be made. Okay, only when the expressions is with the parenthesis. Okay, parenthesis, and the statement that the selected matches the given expression unit of the measurement. So here what happens, once it is evaluated or once it is compared, then what happens, it must select, okay, it must select or else it must match the present expression, it must match the other unit of expressions, okay, which are present in the library. So the block of multiple statements to be sorted out within the begin and end. So here within this begin and end, we will find multiple statements, okay, multiple statements. What? Each statement will have the expression and that expressions are in the parenthesis form. They are evaluated and they can be compared, and after comparing, the matched statements will be evaluated or else it will match with the other statements and then it goes. So all this all the story must be happen in between the begin and end. Okay, all this will be sorted out only within begin and end. So here this syntax talks about the previous slide, whatever we had discussed, syntax followed with the case, and these are the statements. Okay, statement 1 is all about the item 1, 2, 3, 4 and begin and end. So all these, whether they are need to be evaluated and they need to be compared and they need to be matched. So all this will be sorted out between begin and end. Okay, and then by default, again, if they are evaluated in between the begin and end, they need to be evaluated. Once it is evaluated, by default the other statements will come into existence, and that statements parallelly it has to evaluate. Okay, not only the particular statements from 1 to 5 statements, if you are having in this particular begin and end, if you are having begin and end in between 5 statements, 1 to 5 statements, not only this 5 statements, the particular case statement will evaluate, compare and it will match, but also by default it will compare, it will evaluate and also it will match the other statements. Okay, out of the box, out of the begin and end box, it will again evaluate, compare and as well as it will match. Okay, all this thing will happen only in between the begin and the end keyword, and finally I'm ending up with the end case. So in the module 1, Verilog as a module, when we are discussing about the keywords, okay, when we are discussing about the keywords, always we have written the code in terms of module, some adder and the port list, right? Okay, finally I'm terminating with the end module. Okay, this is what we had seen till now, but in this particular case statement, we will see always it starts with the case keyword. Okay, case keyword followed with the statement, and I'm ending up with the end case. So this is the difference that you have to see when it comes to the case statements. Case statement and the normal syntax. Okay, this is the difference that you have to observe. Module, end module, whereas here in the case statement, case, end case. Okay, so the following module, it includes what? 2-bit operations for signal to route one among 3 input bits. So here we'll see 3 input bits. 2:0 means 3 input bits to the sign stated as out. So here a case statement is used to assign correct input to output supported to the value of selection. So here we need to do 3 things, right? We need to evaluate, we need to compare and we need to match. So here that is what we will see in the coming example. I am considering bits of 3 bits. Okay, 3 bits. Out of this 3 bits, I need to by using the case statement, I need to sort out all these things. Okay, and finally the output I must give with respect to the value that I am selected. So the default statement helps to line out to 0 if selection is 3. So here this is the example that I am considering. So here in this example, module, my module is multiplexer. So I am having the input as 2:0. So here totally 3 bit of input I am having A, B and C. So here 3 bit of inputs and 1:0. So totally 2 bits of selection, 2 bits opt for signal to choose from A, B, C. So here my inputs are A, B, C, and here I am having selection lines 0 and 1, and output register I am having 2:0. So output is 3 bit, 3 out, 3 bit signal. I must get the 3 bit signal. 3 bit signal. So invariably block is dead whenever ABC or selection line changes in value. So here what happens? We will see some blockages. Okay, we will see some blockages in the flow with respect to the delay. Sometimes we will see the blocking of the statements, and sometimes we will see the controlling of the statements. So here we will see sometimes we may see the blocking of the statements with respect to the input, that is A, B, C or selection, when they change the values. only when they change the values, we may see some changes to be occurred. That is, whether in terms of blocking or else whether in terms of the controlling. Okay, controlling the bits. So invariably, at the rate, A, B, C and selection, these are the inputs, and I'm beginning with a case. So here is a case statement as we are discussing. It should start with a case keyword and should end with the end case, isn't it? Okay, this is very, this is where we are pondering more on this part. Okay, we know what is module and end module. So in terms of case and end case, what's happening? 2 bits of information, 0, 0, 0, 1 and 1, 0. So when it is 0, 0, my output is A. Why? My selection line is 0. When my selection bit is 0, output can be A. So if it is 1, my output is 1. And if it is 1, 0, that is output is C. So if my selection line 2 is there, my output is 3. Now, what happens by default if I have the output is 0? So if something is, if selection is something that is X or Z, what happens? The output is commonly 0. Okay, so I'm ending up with the end case and finally end with the terminating the syntax with the end module. So this particular example helps us to know how to write the case statements with respect to the input and as well as the output. So when you are writing the case statements, you must remember the 3 things to be followed. One thing is evaluate. So before you evaluate, you must see the expressions with the parenthesis. Okay, the expressions must contain the parenthesis. We need to evaluate and we need to compare and we need to match the output, match the other statements. Okay, so here matching has been done. How? By default, the output is 0. Why my output is 0? If my selection is out of something which is not 0, that is X or don't get conditions, then the output commonly observed as 0. Okay, so in that cases I can write the default statement and then finally ending up with the end case and an end module. So this is how I can write the case statements. Okay, here I have considered the multiplexer. So in place of multiplexer, you may consider any of the combinational logic circuits, that is decoder, encoder, comparator, whatever it is. But this is the procedure that you need to follow. And now coming to the case statement header. So here in this particular statements, we will be learning more about the different case terms. Okay, so coming to the case statement header. So what is this case statement header? It consists of the case. The header consists of the case, that is the header, it could be case Z or case X. Okay, the case header consists of a case with respect to case Z and case X. So these are the keywords followed by the case expression. Usually all on one line of code. So usually we will see these keywords followed with the case Z and case X followed with only a single line. Okay, only a single line of code we will see. And then comes to the case item. So what does this case item? It is that the bit, it is of item is nothing but it is a bit, vector or Verilog expression, accustomed or else expression used to compare against the case expression. So if you want to compare this case item, it helps us to know more about the bit, vector or else a Verilog expression. So in order to know more about or else just to compare the case expressions, okay, we can select any kind of item that is in terms of bit, vector or Verilog expression. So unlike different high-level programming languages like C, the Verilog case statements include implicit break statement. So here, when you compare it with the C language, again, in the Verilog, you will see the implicit, that means what? In the case statements, in the Verilog VHDL, when it comes to the case statement, you will see the break statements. Okay, in the case, you will see the break statements. That means what the break statement says? Break statement says that there is no, the flow of control. The flow of controlling is minimized. Okay, we will see the less term of flowing of the execution of the program. Okay, so here we will see the Verilog case statements. It includes what? Break statements. The flow of control is minimum. And coming to the case statement, case item statement. So what is this case item statement? A case item statement is one or plenty of Verilog statements. Okay, Verilog statements. The case statement, a case item, it is nothing but a plenty of Verilog statement. That if the case item matches this case expression, not like VHDL, Verilog case things can themselves be expressions. So here this Verilog item assignment or Verilog item statement, it is talking about this item statements. It could be one or more than, okay, one or plenty of Verilog statements. In the Verilog library, we will find this case item statements one or more than one. Okay, why means in order to match the case expressions. Just to match the case expressions, we can easily directly the designer can be driven directly to the Verilog library as well. Okay, so just to give the expressions which are obtaining from the given, just to match the expressions between the given from the given library Verilog. So to alter the parsing of Verilog document. So what does this word parsing means? So just to alter, to change, okay, to change the sentence, breakup of a sentence. Parsing is nothing but the breakup of a sentence or else a group of words into separate components. Okay, so to break up a sentence or group of words. This is one group, G1, G2, G3. So group of words into separate components. So this is component 1. This is component 2. This is component 3. So just to change, okay, to alter what? To alter the Verilog code, this Verilog case statements ought to be enclosed between begin and end. That means what? Just to change the code or else to break the word, only in between begin and word, all the case item statements will be considered. Okay, just to break or else to group the word into what? Separate components. Okay, that means what? Here in this, I can talk about a multiplexer with 3:1. Okay, and next I am ending. Again, I am beginning my case sense statements with respect to decoder, and I am ending the case. And finally, also I begin with the case statement with the encoder. Finally, end case, end module. So this is how I can write my code. So here, this case item states that only within the begin and word we can write the case statements with respect to the combination or else with respect to the modules that you are considering. So in order to alter this, we can begin and word, begin and end. In between, we can write the code. So what is this case Z? So case Z is nothing but in Verilog, this case Z statements is a variation of case statement that enables Z and question mark. So here in the case statements, if you find any statement with respect to the output Z or question mark, and then that case would be compared to what? Don't care. Already we have studied about Z and X, isn't it? So X is don't care and Z is also high impedance value. Okay, so these two are nothing but when you compare the enables or else the case statement which if it is enabling Z or question mark, then it is nothing but the don't care values. So Z and question mark unit of measurement is treated as don't care. Okay, if you find this case inside the case expression or if they are inside the case item. If you find this Z and question mark inside the case item or case expression, okay, it says that the values are don't care values. So when secret writing a case statement with don't care, use a case Z statement. So if you want to mention anywhere in terms of case item, in terms of the, if you are observing the value anywhere it is X or Z or question mark, simply mention case Z or simply mention case X. Okay, so the Z characters inside the case things to purpose don't care bits. So Z, X are don't care bits. Okay, whenever in between the case statements, if you are finding in your result that anywhere is a don't care value or is high impedance value, remember or else mention with the case Z. Coming to case X, it is similarly similar like a case Z. So here in the statement, if you find anywhere with Z, question mark and X, then it means that the expression that is to be compared with the don't care. Okay, when you see Z, question mark and X, always remember it is to be compared with the don't care values. So Z, X and question mark, unit of measurement treated as don't care. They can be inside the case item or case expression. Okay, inside the case item or case expression, wherever you are finding Z, X or question mark, you can write in terms of case Z or case X. So these are just a representation of how to write a statement, particular statement, when your output is in terms of Z, X or question mark. Okay, and full case statement. What does this word full case statement mean? So this full case statement is a statement that are gettable case expression binary patterns are matched to a case item or case default. If a particular case expression is matching with respect to the case item or case default, then we are calling that statements as full case statements. Okay, so if a case expression is matching with respect to case item or case default. Okay, case expression is matching with respect to case item or case default, then we are calling it as full case statement. Then if a case statement does not embrace a case default, okay, if a case statement does not having any case default and it is gettable to looking out of a binary case expression and it does not match of any printed case thing, then that statement is not full. So when we are calling it as a full case statement, only when the case expression is matching case item and case default. Okay, but when if it is not matching either if case default or if it's a case item, then we are calling it as a not fully case statement. Okay, the case statement is not fully case statement when if it is not matching, the expression is not matching with respect to the case default statement or else the case item statements. Okay, then a full case statement can be a case statement inside every gettable binary, non-binary or mixture of binary and non-binary patterns. Okay, the full case statement can be a case statement when it is inside binary, non-binary and mix of binary and non-binary. We are calling this full case statement as a case statement only when it is with the, if it is a gettable with a binary, non-binary and both binary, non-binary. Okay, then the case statement follows like this. Okay, then coming to the parallel case statement. So what is this parallel case statement is? It is a case statement inside if it is only gettable to match a case expression to only one case item. So matching case expression to one case item. Parallel case statement. Parallel case statement is nothing but, if it is, the parallel case statement is a statement when it is gettable to match. It must, if it is matching with respect to the case expression with a one case item. Okay, if it is matching with case expression with respect to only one case item, then we are calling it as a parallel case statement. Then if it is gettable to looking out case expression which they make match over one case item, the matching case unit of measurements stated as overlapping case, and so case statement is not parallel. So sometimes what happens, if the statement which is matching with respect to the case expressions only to one case item, if it is matching only to one case item, then we are calling it as a parallel case statement. Sometimes what happens, the matching will be done with respect to the case expressions but not with only one single case item. But if it is matching with more than multiple case items, then it is nothing but a non-parallel case statements. Okay, if it is matching only to one statement, then it is a parallel. If it is matching more than one, okay, more than one case item, then it is nothing but the non-parallel case statement. Then if the case statement is designed as X and Z in the case item alternatives, the result will differ. So sometimes what happens, when you are matching with the expressions and that expressions are consisting of X and Z values, as we know that X and Z values are the don't care conditions, isn't it? So in the case statements, if you are coming up across any expressions with the statements Z or X, then the result will be differ. The result will differ. If they are in the binary, the result will be matched and they compared. But when the expression is with respect to X and Z, then the result will differ. So here, in this particular case statement, we will see the module multiplexer I am considering with the input 2:0, 3 bit of input ABC, and output register 2:0, that is 3 bit of output. So now the case item have X and Z and selection has to match the exact value. So here I have ABC and I have selection lines and I have the output. So here the case item have X, Y, X and Z, for example, and they have to match the exact value, and the output is to be assigned with the corresponding input. The output is assigned with the corresponding input based on this selection lines. Then always @ABC selection and begin. Okay, these are my input ABC selection lines, and I am beginning within the case. Okay, so case what? Selection lines. Based on the selection lines, my output will be observed, and that is with respect to the input. Case select. So this is 2 bit of X and Z. See here, my inputs are in terms of X and Z. Okay, so in terms of X and Z, output is A. In terms of Z and X, output is B. And in terms of X and X, and output is C. So here, these are in terms of Z and X, isn't it? So the case item have, this is my case item, and my case item are in terms of X and Z. So here now, by using this X and Z, I need to match with to the output expressions. That is what A, B and C. So my output I'm getting as 0. End case, and why am I getting 0? Why? Because I'm matching, my inputs are mapping it with the X and Z. So here they don't have values. The value will not be differed, A, B, C. So here we don't see any different values. The output is not differed, right? So why the output is not differed? with respect to the input when the case items are with respect to X and Z. So as these X and Z are don't care conditions, obviously the output doesn't matter. So the output doesn't differ. So here by default I'm getting my output as 0 and I'm ending up with the case, end case, N, and finally N module. So this is about the case statement, and now we'll see the differentiation between the case and if else. So here we will see the difference between the case and if else. Previously we had discussed what are the case statements and how they are going to differ if you are calculating with respect to the input X and Z, and how they are going to differ with respect to the input line 0, 0, 0, 1 and 1, 0 and 1, 1. And now we will see the difference between the conditional statements and the case statements. If else is a condition statement, isn't it? If else is a condition statement, where case is a case statement. And now we will see the difference. The case statement is differ from if else if in two ways. So when you compare these two statements, conditional statements and as well as the case statements, they differ in two ways. So what are those two ways? Expressions given in if else block are more general. So whatever the expressions that we are giving in the if else condition, if is a followed with the condition, right? And then followed with the statement, and then will the if followed with the statement, and if else condition and followed with the statement. So this is a common thing. This is a common. While in case block, a single expression is matched with multiple items. When you compare this case and the conditional statement, we are saying that the expressions in the if else block are general, they are common. But when you compare in the case block, we see the expression is matched with the multiple items. So the expression, it is matched with the multiple items, okay, based on the values. So the case will provide definitive result when there are X and Z values in the expressions. So here the case statement, it gives the different values. When they give the different values, when the input are in terms of the X and Z values. Obviously when the selection lines or also when the input bits you are observing in terms of X and Z values, the output is different, okay, the output is definitive, the output results as 0, don't care conditions. But whereas here in if conditions, there is a possibility of with respect to the statements that you are considering and the conditions that you are making, okay, and the decisions that you are making can be comprised in the if else statements when it compares to the case statement. So this is about the case statements. So we had discussed the different case statements followed with the different examples, parallel case statements followed with the examples. Mostly we are considering multiplexer. We can also take the encoder and decoder, but the important thing when it comes to the case statements you have to remember is the case, it starts with the case and ends with the end case, and all these things will happen between begin and end module, okay. So sometimes with respect to the full case statements, we are saying that the case expressions should be matched with respect to the case item and as well as the case default. If it is not matching with respect to the case item and default, we are calling it as a non-full case statement. And also we have discussed about the parallel case statement, and also we have discussed about different categories in the case items, okay. Sometimes my case items will be case Z and case X. Z and X are the don't care conditions, okay. And also we discussed about the case item statements, and all these case item statements would be considered only in the begin and the end. See, begin and the end. So this is the, I'll show you begin and the end, right? This is the end. I'm beginning here. So begin and the end. In between the cases, we will be writing the cases. So this is about the case statement, different case statements, and finally we had discussed about the differentiation between the case statement and also the conditional statements, if else if condition statements. This is all about today's presentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.